Capital raises and liquidation events are really taking off in the launch sector. Coming off the back of York Space's IPO and SpaceX's merge, iSpace and Stoke Space both lead investments charge, combining for over $1 billion in total funding announcements. Stoke Space extends their Series D raise by another $350 million, while iSpace raised $729 million themselves.
There's a good moon rising as both SpaceX and Blue Origin have announced intentions to focus ambitious projects on more lunar-based missions. Axiom, FAST, and Voyager have all received capital to help service that lunar effort, either by servicing the ISS and current astronaut needs, or by gearing towards the needs and missions of lunar astronauts.
Logos Space must prefer their toast buttered, as they've received approval to launch a 4,000 satellite constellation of Ka, Q, and V-band counter-jamming assets, while Amazon Leo uses every available rocket to get their constellation deployed by the July 2026 deadline.
Welcome to this week's episode of Space Times Podcast. As always, I'm Harrison Lambert,
here with Paul Mayer.
Excited to share this week's space industry updates with you. We hope you enjoy the episode. Subscribe to our newsletter if you want the written breakdown of our episodes emailed to your inbox every Monday morning. Drop us a comment on our LinkedIn or Blue Sky with anything you enjoyed or would like to see. And as always, listen weekly on Spotify, Apple Podcasts, YouTube, or wherever you're receiving this signal. This week, we have major drama in the launch sector, as well as additional news in the space habitat sector and communications. To start us off, Stoke Space announces an extension of their Series D financing round to $860 million, adding $350 million to the initial $510 million raised in October 2025. This brings their total funds raised to $1.34 billion, and this is to develop their product lines, both of the Nova spacecraft and their Bolt line product, as well as developing their Cape Canaveral Launchpad 14 to handle the launch of that Nova rocket once it's ready.
Yeah, that's a massive amount of capital that they've raised. And I'd be interested. Well, so typically when you see an extension of a round, it can mean either that the round was so burning hot, such a good deal that everyone and their brother wanted to get in on it. So it's like, oh, we only needed to raise $1, but there was $3 to $5 worth of interest in the round. So we actually went ahead and raised $2.50 or $3, but we got much more favorable terms. When you see an extension like this, where, okay, we raised $1 today, and then we extended that to raise another $1 tomorrow, generally that's a little bit less of a positive signal. It's generally more indicative that the capital that they raised, or the capital that you raised initially, wasn't adequate, and that you needed to go out and raise more capital, which means either that you didn't raise enough off the bat, or it means that you've been deploying the capital inefficiently. And so usually that leads to some amount of dilution and some negative outcomes for the folks there. Stoke has been doing a great job. So I'm sure that their raise is going well, and that they're not in a position of distress or are doing so under unfavorable terms, unfavorable circumstances. But something to sort of keep an eye out for, that typically when a company goes out and raises multiple Series B, Series C, Series D, when they do multiple raises under the same sort of title for the series, it's generally indicative that things are a little bit more challenging than maybe folks initially anticipated.
You're telling me rocket launch is challenging?
I think I might be.
That's news to me. I can't imagine. I think Vulcan understands that, as ULA had some real challenges this week with their return to flight of the Vulcan Centaur rocket. They had paused launches for 16 months after a solid rocket booster burned through on their third launch last year. And they did that pause to investigate the problem and hopefully alleviate it. Unfortunately, those hopes were dashed this week as they launched the Vulcan again and got another solid rocket burned through again. It was an impressive testament to Blue Origin's BE-14 rockets, the liquid Methalox rockets engines that are used on the first stage of the Vulcan, as they were able to counter a spin that was generated by the burn through on the solid rocket booster. And they claimed they were successfully able to deploy the 3 satellites for the USS F-87 mission, which is a national security mission to deploy 2 geosync comm satellites as well as a geosync RPO satellite for defensive purposes, which is a pattern we've been seeing more frequently out in geo amongst nations. This solid rocket booster is not a great sign for Northrop Grumman, who is the producer of these solid rocket boosters. This is a variant that is twice as strong as the solid rocket booster used on the Atlas V, which has not had these issues. So it's very curious to see why this particular version is failing, whereas the historical use of these rockets is not having issues. And I really hope that this is really just a problem with this specific line, because Northrop also develops the solid rocket boosters for the Artemis, the SLS system, which is going to be launching for Artemis 2 in the next month. And that's carrying humans. And solid rockets always concern me when there's humans involved. And this is not a great sign for the producer. But I'm hoping this is really just an isolated incident, and they'll figure that out, and hopefully quickly, because ULA had recently, like as of last week, announced they're targeting 18 to 22 launches of the Vulcan this year. And this is almost definitely going to dampen those expectations.
Yeah, I'm curious as to how much of this Tory Bruno might have sort of seen coming, or had inclination that maybe there were some challenges coming forward. But it could be interesting. It could be interesting to see what Blue Origin is able to potentially sort of capture if these solid rocket boosters, and if the Vulcan rocket continues to experience some challenges.
Yeah, I mean, Vulcan has like 24 NSSF launches on contract. I think this definitely gives an opening to Tory Bruno to steal some of those away from Blue Origin, since he's now leading the national security effort for Blue Origin. They're not yet qualified to take these contracts, but given his track record, I'm sure it's not that challenging. And if he's able to steal away any of those, that's bad news for ULA, since that's their primary customer for the Vulcan rocket. And there's been chatter, as of last year, that ULA might be trying to sell their business and get out of the rocket launch business, which is not great for the diversity of rocket providers in space. But given that we have a lot of other companies standing up capabilities, I think I don't mind seeing the pattern of stalwart military businesses transferring that kind of work over to newer space companies that are doing it better and cheaper. I think it's particularly interesting this week when you compare it to the success out of Europe with a very comparable rocket. The Ariane 64 is also a non-reusable liquid first stage solid booster propelled rocket with similar launch capacity, similar purpose to the Vulcan, but they were able to launch fully successfully. So their solid boosters performed, flawlessly. This Ariane 64 rocket is a first flight of this variant. The most powerful variant before that was the Ariane 6 with 2 solid booster rockets, but the 64 actually has twice the lift capacity as that variant, just by adding a couple of extra solid boosters. So it's very impressive. They successfully deployed 32 Amazon LEO satellites to low Earth orbit. And this is, I think, a really great indication, again, of Avio's capability of developing solid rockets. They are the developers of the Vega C rocket. They're also the providers for the solid boosters for the Ariane 64 rocket. And we've talked about them many times over the past few months because they've been raking in millions for missile development, both in Europe as well as in America, where they've expanded to support Lockheed Martin and Raytheon's development of missile technology. So everything's coming up aces for Avio. It's a great demonstration of the technology on this rocket. Definitely puts Europe ahead of America in terms of sovereign launch capability, but they're still generally behind in total launch capability when compared to like commercial capacity. This is also a good thing for Amazon, as they need to launch as many LEO satellites as possible. They've been launching on the Atlas V, on the Falcon, the Ariane. They're hoping to launch on the New Glenn once they can get that turned around and launched again. But they are in a race for their lives to get their Amazon LEO constellation deployed, because they need to deploy 1,600 satellites by July 2026, or else they risk losing their spectrum license from FCC. They have pushed back on the FCC, asking them to push that deadline to 2028, because it doesn't take a rocket scientist to understand that launching 1,400 satellites in 4 or 5 months is just not feasible. They only launched 32 satellites on a one Ariane 64, which is a very powerful rocket, and they only have 200 satellites up so far. So to get 1,400 satellites up in 5 months is just impossible. I just don't see how they're going to do it.
I mean, they need to put up 240 satellites per month.
Yeah.
Be putting up 60 satellites per week. That would mean 2 Ariane launches per week. Like that level of cadence just simply isn't supported.
No.
But I don't see any reason why the FCC would decide to extend that. I mean, they've had the same sort of runway that everybody else has had. So, maybe if they're able to show some really good progress, the FCC will go, all right, great, sure, fine. But I mean, the rest of the industry, vultures are circling. There is such a land rush for spectrum licenses that the FCC is not going to have any sort of vacancy or difficulty in finding suitors for that spectrum.
Yeah. So I totally expect Bezos to sue the government again, just like they did with Blue Moon, and probably circumvent the FCC. But given the current setup, they are in some trouble. So there is some traction with commercial launch capability in Europe. Obviously, they've been pouring money into this over the past year, ever since the U.S. has kind of cut ties with funding and provision of space technology to Europe. And they're showing some traction. They're showing some setbacks. Hypersonica this week emerged from stealth with a $23.3 million or 23.3 million euro Series A funding round, as well as a successful test of their hypersonic missile out of the Andoya spaceport in Norway. So this is like the first test. I believe it is the first test out of Andoya spaceport after ISAR had to stand down from their rocket launch a month ago due to a problem with their valves. So great on Hypersonica, especially since it only took them 9 months from development to launch. This is a demo mission, so it wasn't really like ISAR getting to space. This is more Hypersonica proving they can reach Mach 6, which is a really great demonstration. It's not easy to do, but they're still targeting a 2029 deployment of Sovereign Strike capability. So they've still got other key tests like hypersonic controls tests and hypersonic terminal targeting tests. So still a long ways to go, but given their speed and their funding, this seems like great progress for military capability out of Europe. This company is a joint development through Germany and UK through the Trinity House Agreement, which I find particularly ironic since just this week there was rumors that Orbex got bought from their planned acquisition by the exploration company due to UK wanting to keep their sovereign launch capabilities to themselves. The exploration company had been exploring an acquisition of Orbex because Orbex was at risk of bankruptcy. They had run out of funding. They weren't able to raise more. They are really close, like months away from flying their first rocket. But the sale fell through and they are going to go into insolvency. They've appointed administration to handle that. And the rumor is and Skyrora has announced that they're planning to buy what remains of Orbex, but only like tens of millions of dollars of their assets. But it will keep the launch capability in the UK, as Skyrora is another launch provider out of the UK.
Yeah, handful of different things that are really interesting here. The first of which is that Hypersonica has effectively gone from TRL 0 or like 2 to TRL 6, somewhere in that neighborhood, in a time span of about 9 months, which for anyone unfamiliar is just lightning fast. They have made absolutely astounding progress in the time that they've been working on this in stealth. And to your point, there's still a long way to go before they achieve full capability, but they've shown that they can hit Mach 6. They've shown that they can actually hit the hyper in hypersonic, which is the most important part here. So everything else is sort of, second order almost in comparison to just being able to meet the sheer energy needs and the sheer velocity needs in order to accomplish that. So they've been doing very well. And this Series A funding is indicative that they're going to continue to make progress. I would anticipate them hitting TRL 9 in the next 12 to 18 months. And secondly, on Orbex, it's very interesting to see Orbex have a way to continue and maintain their operations by being partnered with the exploration company, which is a German entity, but this would keep a lot of Orbex's competency and capabilities functional and in the UK. So the UK would maintain, we'll say 90% of Orbex's capacity and capabilities, and Germany would gain whatever Germany would gain by partnering with them.
Yeah.
we'll say 90% of Orbex's capabilities and capacity, the same sort of benefit there. But assuming that the UK has sort of torpedoed that deal, now Skyrora is getting 10% of Orbex's assets. It just seems like such a net loss for the sake of keeping that information and that technology sovereign and private. And I mean, if Orbex is a rocket company that is failing and isn't doing well, there's a question of like, okay, well, so how, nothing against Orbex, but how valuable is that actual technical mode? How valuable is their proprietary secret sauce there if they haven't been able to achieve any sort of profitability, and if they are going under? Granted, as we've joked about and alluded to, rocket launch is the single hardest industry to achieve success in. So there could very well be some really meaningful technological differentiation that the UK doesn't want to share with some of the other European nations. But this seems like a very value destroying move.
Yeah, if UK really blocked it just seems so dumb to me. I mean, the main differentiator of Orbex is that's a low carbon launch vehicle. Like, there's nothing unique about it. The German rockets are already more capable out of ISAR and Rocket Factory Augsburg. So it's not like they're giving Germany any sort of leg up on the UK. And what Skyrora is planning to buy from Orbex doesn't even really have to do with the rocket. Like, most of their money they're planning to spend on the Sutherland launch facility, which, I guess it's a great sign for launch facility stand up in EU, especially since Andoya gets that inaugural flight this week as well, and the Malbusca spaceport is being stood up out of Portugal. So, I think this is more a sign that there's a lot of momentum behind getting more launch sites stood up in Europe. But it's a real shame that it seems like Orbex's technology is just being let die.
Yeah, I couldn't agree more. But one of the assumptions is that either everybody else is a fool or everybody else knows something that maybe we don't.
What?
I'll give folks the benefit of the doubt here and say that there's probably some information that we're not privy to that is helping to sort of motivate this. But on the surface, it does seem pretty inefficient.
No, our listeners tune in because we know everything.
You know what? You're right. Between the two of us, we do know everything.
Yeah. We know better than the UK. So China's had some real success, real great success compared to the EU and the US. China Manned Space Agency, the CMSA, has completed what they call an extraordinary integrated flight test, and I couldn't agree more. They were able to test their Mengzhu crew capsule, which is their crew capsule for lunar exploration. They have the Shenzhou crew capsule that they use for low Earth orbit human launch for the Tiangong space station, but this is an upgraded system, believe 7 crew capacity to reach the moon. This is launched on the Long March 10 rocket, which is the reusable variant of the Long March rocket. But the test they did this week was with a scaled down version, the Long March 10A rocket, and a terminal, an abort flight test of the Mengzhu capsule. So they've previously aborted with the Mengzhu capsule on the ground, but this one allowed the Mengzhu to abort at max Q launch of the Long March, which is the hardest, most dynamic part of flight. So they successfully aborted the Mengzhu. They touched down with parachutes. It was great success for that capsule, as well as the Long March 10A being able to touch down on its target, demonstrating their capacity to do reusable rocket. They touched down in the water and they retrieved it with a boat. So it's not like they're fully there yet, but both the Mengzhu and the Long March 10A are able to move on to their next tests later this year. That should get them pretty much the ability to launch the Mengzhu into low Earth orbit, dock with the Tiangong, and at that point, they have operational reusable rocket with a human space flight capability by the end of the year, which puts them in a great position to get lunar human space flight by 2030, which is kind of the target every country is going for. But I think China is moving at a much faster pace than America, where we've had setbacks in the Starship program. Just last week, they announced their pivot to focus more on lunar exploration because of them falling behind with the NASA contracts late last year. and the SLS is kind of getting delayed day by day. They still haven't found the hydrogen leak. So, America is kind of faltering on their movement forward, while China is picking up speed. So I wouldn't be surprised if they're able to kind of pass us on this space race. iSpace in China, iSpace also had some great news. They managed to raise $729 million, which is a huge raise. I mean, it's kind of crazy that Stoke Space announces like their 850 total raise in this series at the same week that a Chinese space company announces something very similar. But great for them. China's been dumping hundreds of millions, billions of dollars into reusable rocket capability. There are 3 or 4 different rocket companies that are working on reusability that we've been covering for the past few months. And this Hyperbola 3 developed by iSpace is to use a Methalox rocket engine, much like the New Glenn, to do reusability, which is a capability that China is very focused on.
So switching gears back domestically here. So in addition to Chinese Mengzhu and the progress that they're making on that launch vehicle and that space habitat, Axiom Space announced the close of a $350 million round. This is for the development of their ISS replacement, the Axiom Station, and their own EVA moon suits, the Axiom Extravehicular Mobility Units. IVA and EVA suits differ in sort of the requirements. Most of the imagery and most of the pictures that we see of astronauts loading in all of the SpaceX suits, those are all IVA rated, but all of the images that we see of Buzz and Neil on the moon with the heavy duty with backpacks on them for life support, those are all EVA. So Axiom making a lot of progress there. This raise was led by Type 1 Ventures and the Qatar Investment Authority and represents a pattern of a lot of different Gulf countries looking to invest in the space industry. So we've seen a lot of partnership and investment and capabilities looking to be acquired by Saudi Arabia, the United Arab Emirates, Qatar. So there's a definite push from the region to get some financial exposure into the space industry and also to build up some space technological capability and some space assets directly. So this is likely not the first investment. It hasn't been the first, and it definitely will not be the last of investments that we see with large price tags and close partnerships with some of those countries in the area.
Yeah, this is a big move for Axiom, and they've had a lot of great traction. They got crew contracts for a commercial crew contract for the ISS just a couple of weeks ago. So they're sending people to the ISS regularly because this is not their first win of that. They launched 2 data centers about a month ago. They got that $100 million in funding from 4iG back in December, which it looked like 4iG is one of the investors in this round. So I don't know if that 100 million is wrapped up in this funding, because we were noting how quickly they deployed the capital. But it looks like some solid momentum there, especially since they were funding them for data centers and they're able to already deploy them within a month, which is very impressive. And Chairman Cam Ghaffarian was one of the investors with his investment fund in this round. So great to have him involved. He also is the chairman on 3 other space companies, Intuitive Machines, Quantum Space, and X Energy. So together they kind of form a great ecosystem for lunar exploration. And I think between these extravehicular suits and space station and the rovers and landers that they're working on Intuitive Machines, he is going on all cylinders, moving across all his companies to develop a really cohesive ecosystem to get us to the moon.
Additionally, Voyager Technologies was awarded a new IDIQ, indefinite delivery, indefinite quantity contract for NASA's Johnson Space Center. This contract has a $24.5 million ceiling. So not the biggest of these IDIQ contracts that we've seen, but it's a $25 million ceiling for a 4-year period to provide full service mission management services to the ISS. This is effectively to handle logistics for the ISS, and this is something that Voyager has done previously.
Yeah, it's good preparation for these partnerships that we've been talking about the past few weeks. They partnered with Axiom Space and VAST on their habitats, and they have their own Starlab habitat. So this is definitely good practice for them to kind of develop out those procedures and protocols for doing operations on these space stations.
Absolutely. Speaking of VAST, they actually won a contract. So VAST is going to be selected by NASA for the sixth private astronaut mission to the ISS. This is VAST's first private astronaut mission to the ISS. It'll be no earlier than summer of 2027 for 2 weeks aboard the station. This effort by VAST has a pretty extensive science and research mission portfolio, we'll say, that includes biological, biotech experiments and some physical science research. So VAST, building on their relationship with NASA, making good strides and good progress on the crewed and manned or crewed missions, and very much tying into the broader theme of growth and preparation for additional orbital and lunar habitats and crewed missions and requirements.
Yeah, it's a nice contract for VAST. They've launched a demo mission a few months ago that successfully deployed, and they have their first space station going up this year. So definitely good traction for them. And again, it's a good practice for them to work on space stations prior to the deployment of their own.
The overall trend of the orbital ecosystem that is materializing with multiple different private space stations and the efforts simultaneously for multiple different moon stations as well is pretty impressive to see all of this materializing in conjunction, in parallel, at roughly the same time. In more immediate news, the replacement for the Crew 11, who returned under medical emergency, I believe just under 6 weeks ago, Crew 12 has launched this week. It is 2 NASA, 1 ESA, and 1 Roscosmos astronaut returning the ISS to their full 7-person crew. So 6-week turnaround, pretty good turnaround for NASA to scramble the astronauts back up, and to also get the launch capacity and the Dragon capsule. I believe this flew on the Dragon capsule with the Falcon 9.
Yeah, which is it's good that they learned their lesson from the Starliner debacle. This was a much quicker turnaround than that crisis.
Hey, next time we'll do it, and next time it'll be done in 6 hours.
Oh, finally beat China at the turnaround time.
We went from what, 6 months down to 6 months to 6 weeks. So I guess I'm sorry. Next time we'll be ready in 6 days.
That's about how long China took to replenish the Shenzhou.
Setting the bar high, but we'll get there. Jumping over to communications, Eutelsat, a company whose 340 satellite order from Airbus we announced last month, has secured roughly €1 billion in export credit financing to procure this order. So they placed the order with Airbus last month. They're now paying for and financing the order this month. All companies involved and all entities involved are French. So we're seeing the premium and the willingness to favor sovereign capabilities play out in real time, but a big financial announcement, even though this is not something that's effectively news, just the announcement of the accounting that's been going into it. Additionally, AST SpaceMobile successfully deployed their Bluebird. So the LVM-3 had launched Bluebird 6, and that Bluebird 6 was successfully deployed. It has 2,400 square feet of surface area. It is able to provide 120 megabits per second, roughly 10 times the bandwidth of prior generations. And AST SpaceMobile is on track to get between 4 and 5 dozen of these Bluebirds operational by the end of the year. They only need another couple of launches in order to do so. They only need, I think, 3, maybe 4 additional launches. So they're making great progress, and things are going very well for Bluebird and the direct-to-device capabilities that Bluebird is offering.
And they're going up on the next New Glenn launch. So things are moving along for them. These are really high capacity launch vehicles. That LVM-3 was the largest rocket that India Space Agency had launched yet. So they are taking all the capacity they can to get these up as quickly as possible.
Logos Space Services has secured U.S. regulatory approval to deploy up to almost 4,200 low Earth orbit broadband satellites. So 4,178 of these satellites going up. They would operate across a multitude of different orbital shells, primarily between 870 and 925 kilometers altitude. So as far as LEO goes, they're on the upper end of that range. Now, this constellation is planned to service as Ka-Q and V-band counter jamming constellations. So they're up there looking at providing counter jamming on these spectrum waves and spectrum bands, the Q and V of which are traditionally less populated than the Ka band.
Yeah, they have a few approaches here to be counter jamming. The unique spectrums allow them to kind of avoid some of the more traditional jamming technology that are targeted more at the Ka, Ku, and X bands. The QV bands are useful for that, but even the Ka band has some technology in there to help avoid it, primarily using narrow beam transmissions between the ground. This allows them to kind of not have a broad area that can be easily jammed from the ground. This creates a higher throughput, but also allows for kind of jamming devices that are coming in at low angles to not have enough power to overcome the transmission from these satellites. So they're taking a few unique approaches to address a very growing problem with military communication satellites.
Additionally, the SDA has operationalized a laser mesh network for the proliferated warfighter space architecture. SDA is now officially pushing for interoperability between different providers. And something that we've spoken about previously, pointing to Rocket Lab as the example of this, is that some of the larger companies have been acquiring different layers of the tech stack. So the SDA specifically pushing for interoperability at this telecommunication and at this networking layer means that owning some of the hardware stacks in that layer is a little bit less beneficial, a little bit less valuable, because you now need to be able to work with everybody, because you now need to be able to interact with everybody. Owning or monopolizing that layer is a little bit less valuable. You're able to extract less rent. This type of push effectively kills any sort of monopoly, because now everybody has to work together. So it really pushes down the margins effectively in that hardware layer and allows for much more competition throughout. So folks like Rocket Lab, who have been buying up some of this capability, it makes those acquisitions a little bit less valuable.
Yeah, and we saw this last month with the Hokusai protocol coming out of Japan. There seems to be a very concerted push to mandate interoperability between laser terminals. I think it's just based on the fact that this technology is being adopted at such a rapid pace. It had kind of a slow acquisition over the past few years, but this past year or so, most of the companies have been bought up. Most of the players that were around for the past years got bought up, and many new companies are being stood up either for new technology or just to capitalize on the demand for this technology. The PWSA mandates that all satellites use laser optical communication terminals. So there's definitely some demand there and the necessity for this interoperability. But we have companies like Kepler Space that are using laser terminals. Starlink has laser terminals. Like all these mega constellations, like TerraWave is going to use laser terminals. There's this giant demand that can only be met by multiple companies working simultaneously on this. And to avoid kind of this fragmented environment, these interoperability standards are really critical.
Yeah, the standards war typically ends in a winner-take-all scenario and a whole bunch of losers. And when there is this much rapid increase in demand, the capability or capacity for any one player to actually service and meet all of those needs just isn't there yet. So for the betterment of the industry, it's a good call that this type of interoperability has been mandated, because otherwise this would without that type of guidance turn into an absolute bottleneck in the industry. AppleLink and Galaxia have teamed up to improve planned data relay capabilities. Galaxia is to fly the RF optical hybrid communication next year. So this ties in with some of the things we were talking about previously, but there's a decided effort and concentrated effort in the industry to solve some of this interlink and and relay challenge that we've seen. And it's good to see AppleLink and Galaxia working together on yet another potential solution.
Yeah, AppleLink's had a lot of big deals coming through recently, but this particular deal is interesting because they are talking about using an RF optical hybrid system, which again goes back to interoperability. Some of the satellite constellations like OneWeb aren't equipped with laser terminals. So being able to create a kind of hybrid environment where you're able to kind of swap between RF and optical is great. Some of the more advanced designs I've seen, like Mynaric, has a way to kind of keep track of a laser connection, so it doesn't have to jump too much and has a better kind of beam width to handle. Could benefit from this kind of technology. So, potentially a Galaxy has a really key advantage with their technology here, and the interoperability is definitely a boon to that.
The Mitsubishi Electric Corporation announced that it was awarded a contract by the Japan Ministry of Defense on February 6th to construct a next generation defense satellite communication system. So under this contract, Mitsubishi will develop and manufacture the next generation communication satellite, which will succeed the current Kirameki 2 satellite, as well as design the ground system necessary for communicating with said satellite. So this is building the military communication successor to the Kirameki 2, and it's the first major contract that we've seen awarded to more or less traditional GEO this year. SatLab Space Systems has secured $1 million to bridge the space data gap and build the future of real-time Earth observation. It's an Indian interstellar satellite or inter-satellite link company, ISL, and we've seen a multitude of different companies looking at solving this problem. There have been some solutions that have amounted to minimizing the processing, minimizing the bandwidth and the size of the data that needs to be transmitted. We've seen some companies that have been trying to solve this by keeping a constant and steady stream of data. So rather than needing to relay down to ground stations, be able to just beam that data simultaneously across a much wider berth, hitting sort of anyone and everyone that they need to hit. But real-time Earth observation is very much a challenge. It's very much a needed solution. And we've seen that being solved more often than not with the laser optical terminals, with the transmission layer being part of the big solution there. So it's good to see additional players entering the space to help solve that and bridge that gap.
Yeah, particularly for India, who doesn't really have an optical terminal player here yet, but they are very experienced with optical Earth observation. So this is a great capability for them to stand up. I didn't see if they specified if it would be an optical intersatellite link. There are RF intersatellite links like Iridium that's been around for a while, but I would expect them to move towards optical since it's being proved out on many constellations, and the throughput's much higher than RF capabilities.
Sure. I mean, for anything real time, I can't imagine that an RF intersatellite link is going to be able to provide the bandwidth necessary to support that type of product. But
yeah, I mean, we saw like last month with Aurora Tech flying on Kepler using the optical laser terminals to do real time fire monitoring. But for $1 million, I can't imagine SatLabs can develop an optical terminal off of that. So either we see some more raises coming for that company, or they really are just trying to stand up the first layer of the intersatellite link using RF capability.
Well, either way, best of luck to them, and we're glad to see them entering the market. German startup Constellar, a global leader in thermal intelligence from space, has raised a 37 million euro Series A, one of the largest Series A rounds in European space technology to date. It's been led by Alpine Space Ventures and Lakestar, and this investment is intended to accelerate the expansion of their fully operational thermal intelligence capabilities and advance the system to defense-grade status for governments, military entities, and security agencies. So they are working on a sub-5-meter thermal infrared imaging satellite with major defense capabilities demonstrated. I think there are some non-defense players who would argue that they themselves are the leaders in infrared and thermal imaging in space, but the the defense and military capabilities of what we've seen here rival the value add and the defensive capabilities of what ICEYE has been providing, what traditionally SAR has been providing. So this Constellar is effectively demonstrating that thermal imaging and the infrared wavelength can be just as valuable for national security as SAR has been. So I would not at all be surprised to see Constellar continue to grow and to see some of the other players in the space. We've spoken about HydroSat recently, who has their own thermal imaging and infrared technology stack. But I would not at all be surprised to see other folks try to enter the market and get in on what is quite likely to be another massive source of NatSec and defense investment.
Yeah, I mean, HydroSat's not thermal infrared; they're near infrared, which seems like a weird distinction to make. But the wavelengths are so dramatically different that the sensors that you need are significantly varied. There's not a lot of thermal infrared players. Most of them have been nation states because the imagers needed are so difficult and the resolution is so low. And in order to get high resolution or high throughput, you need large satellites. So there aren't actually a lot of satellites that are operating in thermal and infrared, even though the applications are great. Like you said, Constellar has demonstrated capability already. They were able to track Russian submarines through the Arctic Ocean using the thermal infrared signals that were given off by the propulsion units on the submarine. So crazy capability, very similar to synthetic aperture radar, able to see through clouds, able to see at night. It gives some great capability to augment traditional imaging for space defense. And I wouldn't be surprised to see them get like another $1.6 billion Rheinmetall agreement out of this, but probably not to that scale. The only other companies I know that are kind of competing in this area are SuperSharp, who we announced a couple months ago is working on the Hibiscus TIR, which had a similarly high resolution, around 5 meters. They're out of the UK, so it'd be interesting to see them both kind of stand up this capability around the same time. But definitely a useful capability, and it's a lot of money to develop it. So hopefully they get some more satellites on orbit soon.
Yeah, I mean, an interesting distinction to make here is that, drawing comparisons to what ICEYE has done with SAR before there was this global push for defense and national security orbital capabilities and the assets that go into that. Before that was the case, ICEYE had already sort of established themselves as the leader in SAR for the most part. So there's a little bit of a difference here in the sense that both the UK startup that you mentioned and Constellar themselves are effectively nascent. They're not already established. They're not already the incumbent winner for that sort of thing. So to see a 1.6 billion euro Rheinmetall contract come out, it's not like that would be something that anyone already has sort of a lead a horse or a favorite to win. This would effectively be sort of open season, open land grab, where anyone who wants to play in the TIR technology stack would be able to get sort of an equal shake at that money. But I think, sort of to your point, the fact that there are so few players and that it is, as far as a commercial sector, it is so nascent, means that we're going to see the folks who have been doing this get the first bites at the apple. But I would not at all be surprised to see multiple other startups enter the space, anticipating some large contracts to come their way. Wardstone has raised a $5 million round. It is the first funding to officially develop space-based interceptors. So the militarization of space is here, whether we like it or not. Now, what Wardstone is doing is effectively deploying a minefield in the path of the target they wish to intercept. It involves dropping a bunch of debris in the space that will disrupt, inhibit, or altogether stop the missile, the satellite, the adversarial object, what have you. And if this description sounds like it could be potentially problematic for space, that's because it is. Intentionally using introducing and weaponizing debris in space is a very risky, almost sort of prisoner's dilemma, tragedy of the commons situation where, if one person starts doing that at the expense of everybody, it's a slippery slope before everybody starts doing that at the expense of everybody. And LEO, or the more populated orbits today, become more or less unnavigable.
Yeah, it's an unfortunate way to approach the difficulty of kinetically stopping a missile. There were a couple of companies that announced that they were pursuing this last year. Apex Space had their Orbital Magazine satellite that they're planning to launch this year, and Lockheed announced that they're pursuing the same on-orbit interceptor, space-based interceptor program. So this is about the third company I've heard of that is working on this, but they're the only ones that have kind of taken this approach to it, which will likely solve the technical challenge. And it is interesting that this is the first one to receive outside funding for this sort of development, as both Lockheed and Apex said that they were going to internally fund their development.
Yeah, interesting that this is one of the first efforts that has been explicitly and externally validated and invested in to do so. I certainly hope that this does not become the standard. Software-defined AI compression startup secures $3.4 million to, quote, unblock the space-to-ground bottleneck. So they are addressing the critical 2% problem in Earth observation. The compression company closed this round of pre-seed money led by Long Journey Ventures, and it compresses homogeneous features like water and clouds, which traditionally have been a pretty big source of challenge for Earth observation and the data downlink problem.
Yeah, this is a huge issue with Earth imaging. I think the statistics are something like, well, the 2% problem they're talking about is like only 2% of images captured on orbit or downlink to the Earth. And of that, the statistic I've seen is like 90% of them are covered by clouds. And it really sucks when you spend money and time downlinking an image that's just clouds or water. So their proposal to use AI to kind of detect that on orbit and compress it more vigorously than standard compression is an interesting proposition for AI and could be very valuable to a lot of Earth observation companies.
I mean, it's very much falling into the same edge compute value add that we've seen be very popular over the past few years, effectively putting a little bit of compute, using a little bit of edge processing power in order to save orders of magnitude of downlink and data bandwidth needs. So we've yet to see anybody sort of come out and establish either sort of a marketplace for the AI stacks that would be necessary for that, or to establish sort of a method of actually downloading and transmitting that data. There have been too many sort of chickens and eggs to solve simultaneously, but it's good to see the compression company explicitly focusing on like, this is the link in that chain that they are focusing on, and they're single-handedly solving that. And I think that once we start to get another couple of companies that enter the space solving singular links in that same chain, we'll start to see these solutions materialize more rapidly.
Yeah, there are some companies that are doing it, but they're mostly like detecting if there's clouds, and if so, just outright rejecting the downlink. This seems like a better approach, but we'll see how much they can compress it.
The UK Space Agency awarded contracts to Spaceforge, Orbit Sky, and BioOrbit worth a combined $1 million in change to advance in-orbit manufacturing. So they will be developing semiconductors, ZBLAN, and cancer therapeutics, respectively. Something that we've spoken about a couple of times over the past few months here, the growth of microgravity manufacturing at scale and the value that can add both on an orbital and terrestrial basis. So interesting to see all of these companies getting some traction from the UKSA, and good to see all of these companies growing simultaneously. Additionally, Deep Space Energy closed their pre-seed round, bringing their total R&D budget to just under €1 million, 930,000. The Latvian company is working to develop the americium radioisotope generators for satellites and lunar applications. Do you know what that means?
The americium radioisotope? No, it's a certain element that can be used. It's like it's a waste product from nuclear reactors, but they're able to use it in radioisotope generators. So typically we see like plutonium radioisotope generators, like on the Voyager mission, some of the lander or the rover missions. But americium, I think it's less used, so maybe more cost efficient, but we should give them the same benefit of having a secondary power source that's safe from. They're talking about keeping satellites safe from interception from adversaries that could like knock out their solar panels. They would still have this radioisotope to give them power. So there's some defense implications there, which might be able to drive some of their funding, but they seem focused on the lunar applications, which is not without precedent. I think the radioisotope generators have gone to Mars though, not the moon. But when we talk about lunar, the dark side of the moon and lunar winter and trying to survive long nights, like this is a technology that needs to be developed. So it's a unique approach to that. So for tech advances this week, these are news stories that fall outside of the main topics or business advances. We have a big one for a few companies. The NRO has added SatView, HEO, and Sierra Nevada as commercial solutions partners. So this basically pre-clears these three companies to be able to supply imagery to the NRO. This is a great boon for all these companies in order to have new revenue streams. It makes it a lot easier for them to bring in capital from NRO, who buys a lot of data. So pre-clearing them is great. SatView is a midwave infrared imager. HEO is primarily a non-Earth imager, but I've seen them talk about Earth observation as well. And Sierra Nevada is the company working on the Dream Chaser. So it's good that they have another revenue stream coming in now that the Dream Chaser has been kind of sidelined by NASA. It sounds like the NRO is going to use their imagers for non-Earth imaging primarily. So some of that defense application of protecting satellites, but surely also for some Earth observation applications. Scientists have developed a new deep learning framework called DeepLaDo. It is to optimize laser intersatellite links in LEO mega constellations. This enables high-capacity backbone connectivity for non-terrestrial networks. I found this algorithm really interesting because they're basically using AI to optimize the topological mapping of a intersatellite connection. So the topology that they're generating is to create the best path for keeping intersatellite link connected. This minimizes the number of hops it needs to make between different laser nodes, and that maintains the connection for longer and allows them to narrow the beam, which increases the throughput of the laser satellite link. So this AI is meant to improve the throughput of the laser satellite links, which is great to see since this is such a booming technology and does require less development on the hardware side of things, which is traditionally what I've seen with these kind of equipment when they try to improve the throughput capability. So hopefully that algorithm gets implemented somewhere and further development is done, because right now it's just a research paper. StarCloud announced a partnership with AWS. They have announced that they will launch the first AWS outposts on their second satellite launching this year. AWS has not launched a data center yet. They did announce a few weeks ago the TerraWave project to deploy a mega constellation of optically connected satellites to downlink 6 terabits per second. And last week we announced their partnership with AT&T to connect their Amazon Leo constellation to the ground fiber network that AT&T operates. So lots of news coming out of AWS in terms of developing their communications layer, which is the necessary component to orbital data centers. But this is the first announcement they've made of actually deploying orbital data centers. So these outposts will operate on StarCloud. StarCloud has previously flown the NVIDIA H100 GPU in space successfully. So great traction for StarCloud, as they're one of the new space competitors in a rapidly growing and very competitive space, which is orbital data centers, which is pretty much being dominated by SpaceX right now in the news cycle. But there's lots of little players that are trying to cut out their piece of the pie, and StarCloud is the biggest of the little players. I think it reinforces a nice trend that I'm seeing, which is collaboration between other players. Last week we had Google announce their partnership with Reorbit to fly their orbital data centers. So we're seeing something very similar with AWS here, and I would expect to see it with other major players. Yeah, NVIDIA are probably not going to fly their own data centers, but partnering with StarCloud gives them a good connection to this growing industry. Spatium, which is a space refueling company, has successfully demonstrated the robot arm demo. They developed and flew this in 5 months. It launched on a deorbit Ion vehicle last month, and they were able to just this week demonstrate the capability of the robotic arm, which they claim will be necessary for refueling. They seem focused on the refueling aspect of space, which is a pretty small and nascent market. Orbit Fab's kind of one of the other big players in that area. But I find the robotic arm capability much more impressive. There are not very many companies that fly robotic arms. MDA Space is kind of the famous one with Canadarm on the ISS. But trying to find another company that flies a robot arm is pretty rare. So having a new capability and the state-of-the-art capability at that is great. They're able to demonstrate a 0.003 degree accuracy, rotational accuracy on the robotic arm. So at the tip of the robotic actuator, they're able to move it within 1 millimeter accuracy, which is great for this kind of activity.
Yeah. Amazing turnaround time, them being able to go from start to flown demo in just 5 months.
It's a very small team.
Yeah, that's the only way that makes sense to me is if their starting point is amounted to like TRL 5.
Yeah, and I think they've been around since 2024, so they've had a few years to work on it, but it sounds like their whole acquisition development time and launch timeline was within the past 5 months. Which is still great, but I'm sure a lot of work has gone into developing this because it's not an easy capability to stand up. It's not a cheap one either. I haven't heard of their funding, but off the news of this, I'm sure they will receive it soon.
Yeah, I can't imagine that a star-studded performance like that doesn't help them close whatever round of funding they need.
Yeah, and like I said, it's a big gap in the RPO refueling ISAM kind of industry, which is really going through a growth phase right now, mainly off of the back of defense needs. Even though they're positioning themselves for refueling, I think the bigger demand here is definitely for defense applications. I mean, the big news for robotic arms I've seen recently is like Tiangong equipped a offensive robotic arm to their space station to defend against other satellites approaching it. So you can see how some of the applications for this are more in the defense aspect of things.
Sure. I mean, what I find more impressive is the fact that the robotic arm effectively allows you to retrofit your solution to assets that are already on orbit. Most of the solutions now amount to like, okay, well, for everything that you're about to send up, for everything future facing that goes up, you attach with this, that, or the other piece of hardware, and then that's how we're able to provide these on orbit servicing solutions moving forward. But there's very few players out there who are demonstrating the capability to actually do this retroactively with assets that are already up there. And a robotic arm this articulate that has proven out this much capability is that's the unique value at there, is that they're able to address the tens of thousands of potential assets that are currently on orbit that would be better suited being repurposed rather than being completely trashed and deorbited.
Yeah. Playing in that same defense RPO kind of space is a partnership coming out with Psionic and iMetalX to develop the next generation space operations for the U.S. Space Force and SDA. This is integrating Psionic's object classification and tracking software into iMetalX's space battle management software.
Psionic is a team with whom I am more familiar than I am iMetalX, and the team at Psionic is star-studded. They are incredibly capable and talented engineers who have built some truly amazing technology. And it's wonderful to see this partnership materializing and to see both of these companies getting some traction and winning some meaningful awards here. So congratulations to both friends of the show.
Momentus has announced that they will deliver a NASA CubeSat to low Earth orbit to demonstrate joint rendezvous and proximity operations, as well as formation flying. Central to the mission is NASA's R5 spacecraft 10, which will act as a free-flying imager for Momentus's Vigoride-7 orbital service vehicle to assess spacecraft health and performance. This is I can't even keep track of how many different missions Vigoride-7 is flying. But I think this is like the dozenth one on there. It is a CubeSat. which makes more sense given that they're planning to launch V7 in March of this year. So integrating a new customer on this close to launch is kind of surprising. But it's a great alignment with the general purpose of Vigoride 7. They have some large deployable structures for some defense agencies. They have a on-orbit printing kind of service as well. I think this falls more in line with their demonstrations for RPO, which is what this spacecraft is mainly targeting. They have orbit fab sensor flying on board this spacecraft that they're going to be testing out for object tracking for their RPO capabilities. So this combination of orbit fab sensor as well as a NASA sensor that free flies along with it is great for developing the kind of technology they want to build out for RPO. So really excited to see Vigoride 7 launch in March. Hopefully these RPO demos go great and they're able to demonstrate their own capability to do in-orbit proximity operations. Lastly for today, there's an article out of Wired covering General Galactic. I wanted to cover this because it is based on a company that is doing water-based spacecraft propulsion, which is a pretty rare technology. Coincidentally, Momentus is one of the other main players in that field. They've launched 3 satellites, of which I worked on my last job, using microwave electrothermal propulsion, which uses water to create plasma thrust. General Galactic's taking a slightly different approach. They're using electrolysis to separate hydrogen and oxygen to create a chemical thruster so that they recombine and burn it. There's a couple other companies playing in this space, Argo Space and Pale Blue, but this is this approach kind of leapfrogs some of the plasma development does chemical thruster. So always great to see another player in this space. Water propulsion is not the most popular, but if somebody can figure it out, it has huge implications for interplanetary travel, asteroid mining, just the future of space exploration.
Well, that is a wrap for the week's recap of the space industry. We hope you enjoyed the episode. And as always, please drop us a comment, check out our socials, and follow us on Spotify, Apple Podcasts, YouTube, our newsletter, or wherever you are receiving this signal. Until next time, this has been Paul Mayer and Harrison Lambert, signing off for now.